Furat, Furat, do you hear me? I think empty goes to Muhammad Tahir. Muhammad Tahir?
Yes, sir.
Oh, okay, good. Furat,
Uh,
Furat?
Hi, sir.
Okay, hi, hello. Okay, good. Okay, I think now we are ready. Just waiting for your classmates to join us. Then we are going to start the first class with Zoom. Okay. Now in my desktop, the recording has started. You can do it by yourself when I'm going to start my class.
Sir, are you going to upload the records or we
Ye-
are going to do?
Yes, yes. I'm gonna. I have my YouTube channel, so
Okay.
I can post the records there. Then I can share it with you. This is the first option. The second option, I can post all the records using the web page given to us from the AUK. And the third option, you can do it by yourself. I'm going to give you the permission to record. So you can record whatever you need and you can put it in your desktop directly. So, what options would you like to do? You can follow it.
Sir, I think first option is great. You post it on your YouTube channel.
Yes, this is much better than the others because you can
Because
find also. I mean, I'm teaching now three universities, so fortunately, web test analysis is one of the courses given the three universities. So, I mean, if you couldn't catch me here, you can look at it with different universities. But I think you do not need to do that. If you're going to follow me, you will be fine.
sir, and is it the same syllabus as other
Of
universities?
course, this is the same. This is universally used. This is the same for well test analysis. It doesn't matter if it is PGE 490 or PNGE 440 or WTE for I don't know what is the number given by the technology University of Technology, but it is well test analysis.
Uh-huh. Sir, and is this course related to well control course?
No,
I don't know, but because well control course prerequisite is well testing.
okay. Now, the prerequisites is something different. When we need to talk about well control, it's a little bit different topics than the topics covered by well test analysis.
Mhm.
However, the prerequisites could be for the knowing how to use the mathematical models, especially for the pressure distribution. But it does not mean that there is some connection between well control and well test analysis. Of course, now if you ask me, is there any connection between well test analysis and production engine? I could say no. In reality, there should be some connection regarding the mathematical models. I'm talking about, for example, the solution of the diffusivity equation. So I don't know. I mean, if the well control does need one to be, let me see, get succeed with well test analysis. In my point of view, it's not necessary. See what I'm saying?
Yes, sir.
Right now, I have three only. I have Ahmed. Ahmed, hello. Ahmed. Ahmed. Ahmed, do you hear me? Ahmed Barwari. Ahmed. Let me see my second laptop and see if I can get them from Microsoft Teams. Muhammad, your Muhammad and Firas, your name is there, but let me check. Who's there? Who's there? Mateen?
Yes, sir, I'm here.
Mateen, I told you to use Zoom.
Okay, sir, I'm working on that, but I cannot find that.
Well, you cannot find what? You just click on the link given to you, and there is a password given to you also.
Okay. I'm doing it, sir, but it's
Okay,
not
okay.
working.
Yes, I think because this is the first time, so you may have some difficulty. Don't worry, you can get it.
Sorry, sir.
Yes, Ahmed? Ahmed?
Alright, sir.
Furat, yes.
Sir, we don't need password. We only click on the link and we will be in.
Not all of you. Some of you may need for a password. I know that, yeah.
Oh, okay.
Yeah. Lawan? Do you hear me, Lawan? Lawan? Regine? Lawan? Yes. Lawan? Ahmed, you have two accounts now. Why? Oh, now it is one. Joanna? Jawan Saleh? Jawan? Would you please go to Zoom? Okay. Regine, do you hear me? Regine? Regine?
Hello, sir.
Hello? Yes, Ahmed.
Can you hear me now, sir?
Yes, it is very clear now.
Yes, I was hearing you, but I was talking. I think you couldn't hear me.
No, now it's good. Now it's good.
Okay, sir. Sir, can we record the lecture in Zoom?
Yes, of course. When I'm going to start lecturing, I'm going to give you the permission to record by yourself. I'm going to do it by myself. Then I'm going to put it in my YouTube channel and share it with you.
Okay, sir. That's good.
Mateen, are you still trying?
Yes, I'm entering the password.
Okay, good. Okay, here is Mustafa also. I got Mustafa now. Mateen, okay, I got you. Mustafa, Mateen, do you hear me? Mustafa, I got your name using Zoom, so please go to Zoom.
I know, but we are waiting for the host. You are the host.
I am the host, yes.
Okay, we are waiting for you.
I got you the permission, then I lost your name.
Okay.
Would you please do it again? Adnan, where are you? Adnan. Lawan. Regine. Okay, Mustafa, now you are here. Mustafa, you are here now. Okay, good. You are very welcome.
Thank you.
Lawan, do you hear me? Lawan?
Yes, can you hear me?
Yes, please go to Zoom.
Okay.
Maybe some students have been used to that, but we are sorry, that's our first time.
Yes, I know, because it is the first time. I will be a little bit patient with you. But believe me, when you're going to continue with Zoom, you will feel more comfortable with it. It's not because I used to use Zoom always, but Zoom is already designed for educational purposes.
Okay.
It's not like Microsoft. Okay, I got the one now. Yeah, wonderful. Let's see. Regine, do you hear me? Regine? Hello? Regine, do you hear me? I think the internet there is not good, so I'm gonna keep it open, both of them, Microsoft Team and right now I have 6 in my list, but I'm supposed to have 11. However, I think 5. At least I know Regine is trying to get the connection, but the others still not. I don't know why. So right now I'm gonna start uh, my class for this day. Listen, guys. Now I'm gonna give you the permission. There is one with iPhone. I don't know whose iPhone. There is one with iPhone. Yeah, iPhone. Who are
What
you?
do you mean, sir, with iPhone?
Okay, he used iPhone without putting his name, writing his name. Okay.
Oh, okay.
Yeah, let me see. Probably Regine or I don't know. Okay. Who is using his iPhone? Who is iPhone? Because I need to know the name. Okay. We will check it later. Okay. So guys, right now I'm gonna give you all the permission to record. Okay. So okay, let me see. Ahmed, okay. Farad, allowed to record. Now you do have the permission to record. Who is iPhone? I need to know who is iPhone. Please give me your name. Who is using his iPhone? I need your name, please. iPhone. Muhammad, you have the right to record. Mateen, you have the right to record. Lawan, okay, you do have this right. Furat, you do have this right. And Ahmed, you do have iPhone. You do have the right to record, okay?
So
And
each one of us should record by himself, or
if you would like to make it by yourself, I don't mind. I am recording now. Just in case if there will be something wrong with me, you still have your copy. See what I'm saying?
okay. I mean, in the Teams, we just record once, and it will be on the Teams for all the students.
Yes, it is the same here. It is the same here. But okay, I am recording now. I'm recording now, and just in case if I have some troubles, you still have your copy. Okay. I just need to be. I just need to be sure that everything is going very well, and there will be no missing items here. Okay. And here is another iPhone. So I do have two iPhones. The other thing, as a policy for
Call names.
yeah, yes, there is no names.
Sir, iPhone is me, Adnan.
Adnan, okay, and Adnan, I do have two iPhones. I don't know which one is yours. Would you please talk to me? Talk to me.
I will join through my laptop, sir. I will try to.
I got you now. I can change your name now. I can put it Adnan.
Okay.
Okay.
Okay, you got it, sir?
Wait, just wait. Yeah. Is it good now, Adnan? Do you see your name?
I can't see from my phone.
Yes,
I can't see it now, Adnan. I can see it.
I can.
Okay.
Okay.
Good. And the other
Okay,
iPhone. Okay. So let me tell you something. The policy for Zoom, we will have 40 minutes, and there will be the disconnection. When we will have the first disconnection, I am going to rejoin Zoom, and then you need to reconnect yourself with me. Each 40 minutes, 40 minutes, there will be kind of disconnection. We will have a break of 5 minutes. See what I'm saying? We will have a break of 5 minutes. Then we will join again the same meeting. Is that clear?
Okay.
So what we will have a class of 40 minutes, 5 minutes break, then a class of 40 minutes, 5 minutes break, and then the last part of your class. This is what we will have, okay? Okay. So now let me share with you what we have. Do you see this one, guys? Do you see this one? Do you see this slide?
Yes, sir.
Is it clear for all of you?
Yes.
Yes, sir. Yes.
Okay, good. Do you hear me very clearly?
Yes.
I guess yes. Okay. Okay. So let me start with what we have taken last week, because last week we have been using Microsoft Teams. I do not have the tools for annotation. So I'm going to get back to the diffusivity equation. And this is the diffusivity equation. As you can see, guys, here, this is the diffusivity equation. See, here's the diffusivity equation. See, what type of mathematical model is this? As I told you last week, this is non-homogeneous, second order, partial differential equation. And of course, we have different types of the diffusivity equations. Depending on the type of the reservoir that we could have, and when I say the type of the reservoir, I'm talking about the reservoir geometry. If we have a circular shaped drainage area, then we will have the cylindrical drainage area. This diffusivity equation can be used, because in this case, what we need to define the pressure distribution by the polar coordinate. What are the polar coordinates? R and theta. But if you have rectangular shaped Greenwich area, like square, like rectangle, then we have to use the Cartesian diffusivity, Cartesian coordinate for describing the pressure distribution in this type of reservoir geometry. So it doesn't matter if you have the Cartesian or the polar system. We are talking about the mathematical model that could give you the pressure distribution with time in the porous media. And as I told you, this model is called the diffusivity equation. Now, this model, I mean, this model 112, this is, as I said, this is for circular shaped Greenwich area. This model is developed using three mathematical models. One of them is the energy equation. And we know that the fluid cannot move from point 1 to point 2 in the porous media without some change in the pressure. And the second one is the continuity equation that says that the flow rate U, the volumetric flow rate of U, comes from what? Comes from cross-section area times velocity. And the third model is the Darcy law. So when we put the three models together, we can have the diffusivity equation. Moreover, if we have gas flow, we may need to use the equation of a state. The equation of a state says that P times V equal to Z nRT. It is not enough to use these 3 or 4 models to develop the diffusivity equation, but we need some of the assumptions that could make our life easy, that could make, I mean, the way for developing such models a little bit easy. So we need for some of the assumptions, like what? The porous media, as you can see, let me change the color. So the porous media, as you can see here, should be isotropic, horizontally homogeneous. What does it mean, isotropic, guys? I explained this point to you. Isotropic means that the permeability in the horizontal plane, X and Y, is the same for the permeability in the vertical plane. In this case, we can say, okay, we have isotropic formation. If the horizontal permeability, K sub H, is not the same to the vertical permeability, K sub V, then we can say we do have an isotropic formation. Okay, this is good. Now, how about horizontal homogeneity? Now, one of the big challenge for us in the petroleum industry that we do not have really homogeneous formations. Always we have heterogeneous formation. What does it mean homogeneous? What does it mean heterogeneous? Homogeneous formation when all the physical and petrophysical properties, all of them could have the same value at different locations, different points in the porous medium. For example, the porosity at this point, the porosity close to the wellbore, should have the same value to the porosity close to the reservoir boundary. In reality, in the real world, we do not have something like that. So we are not expecting to have homogeneous formation, but we can assume that we could have homogeneous formation. In reality, we have heterogeneous formation. This is the second assumption. Now, uniform in thickness. This could be accepted. Reservoir thickness, H, it could be uniform. Now, when I say uniform, I'm not talking about the vertical plane. I'm talking about the horizontal plane. So reservoir thickness is going to be constant everywhere. We could accept this assumption. And there should be constant permeability and porosity. There should be constant porosity and permeability. Now, this assumption is really different from the assumption of homogeneous and heterogeneous formation. Now, when we could have constant porosity and permeability, I'm talking about with time. I'm not talking about with space. I'm talking about constant porosity and permeability with time. Why? Now, because of the production process, we are losing what? We are losing the pore pressure. We are losing the pore pressure. Now, in the petroleum industry, we do have two pressure terms. The first one is the lithostatic pressure. Comes from what, guys? Lithostatic pressure comes from what? Do you know lithostatic pressure comes from what?
Sir, the formation above the reservoir?
Exactly. This is the overburden pressure. This is the weight of the rock above the layer. And we have the hydrostatic pressure. Hydrostatic pressure comes from what?
Doctor, you said hydrostatic pressure or overburden pressure?
No, no.
Fluid.
Lithostatic. Lithostatic.
Ah, okay, okay. Hydrostatic is from fluid.
Exactly. And
Yes.
of course, we have the effective pressure. What is the effective pressure? The difference between lithostatic and pore pressure. See, because of the production, we are losing our pore pressure. So the effective pressure is going to increase, which means that the overburden pressure is going to be more than the pore pressure. This is going to cause what? This is going to cause kind of compaction. The compaction, this could happen with time. I'm not saying that the compaction could happen after 1 year. No, it could take a really very long time, but it is going to happen at some time. Then because of the compaction, the porosity is going to reduce. And because of that, the permeability is going to be reduced also. So there will be some change in the porosity and permeability with time. Now, for the diffusivity equation, we're going to assume this change and these two changes, let me see, are negligible. Okay, good. What is the second assumption? Single phase flow. This is one of the big, very big actually assumption used for developing the diffusivity equation. When we could have single phase flow, we could have single phase flow if we have either gas reservoirs such as dry and wet gas reservoirs. Initially, we have gas reservoirs. Or if we have black oil. Black oil, now when I said black oil, I'm talking about the volumetric reservoirs. But for the pressure greater than the bubble point pressure, we could have single phase flow of oil. Okay. Can we maintain the pressure always above the bubble point pressure? Of course not. Again, because of the production, the pressure may slide down the bubble point pressure. Then what we will have? We will have two-phase flow, oil and gas. Now, one of the big challenges for the diffusivity equation solutions is how to deal with multi-phase flow, because most of the solutions for the diffusivity equation given to you in the textbook, most of them for single-phase flow. And believe me, there is no mathematical model that could deal with the multi-phase flow in the literature. No, we do not have something like that. And we do not trust all of them. The other thing, the viscosity remain constant. This is for oil. And for gas, we cannot assume something like that. Because, as you know, the gas is compressible material. The gas is a compressible material, which means that the viscosity is going to change with the pressure. There will be significant change in the viscosity. So we cannot assume that the gas viscosity is constant with the pressure. No, we cannot say something like that. But for the oil, yes, we can go with this assumption. Now, the well is totally filtrate the formation. Here is another point. In our industry, guys, listen, now we have 10 minutes. We have 10 minutes until the first disconnection. We will have when we will have the first disconnection. This day we will not wait for 5 minutes because we have started a little bit late. So we're gonna join directly after the disconnection. Okay, so please rejoin me again. Now,
Okay, sir.
yes. Now, in our industry, we may not have 100% completion for the target zone. If you have high water table, then you may not need to have the production casing all the way down to the bottom layer. When you have gas cap and you do not need to produce a gas, then you may not need to perforate the gas cap zone. So sometimes we may have two options: partial completion. The production casing is not going to penetrate the formation 100%, or partial perforation. Partial perforation, for example, you're going to perforate the midsection of your production casing in case if you have water support or gas cap. Now, if you say, I have 100% completion, 100% perforation, yes, we could have something like that, but not always. Gravity force, we are going to say that we have totally horizontal layer, so there is no impact for the gravity force. If it is not totally horizontal, then we have to consider the gravity impact. This is not important. The pressure gradient, this is not important. And the fluid density is given by this model. So here is the assumptions for the diffusivity equation. Now, why we need to know that? Actually, when we have the solution given by the diffusivity equation, we have to think about the impact of these assumptions on the result. How can we reduce the impact of these assumptions on the result? Here is another story for the diffusivity equation. For example, for heterogeneous formation, we do have some of the solutions for the diffusivity equation, considering that we have heterogeneous formation. For the case of single phase flow, we may have some of the solutions. Are they really accurate or not accurate? This is another point. Okay. For the viscosity, if we have gas flow, yes, we have some of the solution for gas flow. Okay. So let us move. Now, look at this model, guys, again. This is the diffusivity equation here again. This one is written in the field unit. Field unit. See, this is field unit. Now, when I said field unit, the pressure in this case is PSI. R, radius, fit, porosity, fraction, CT, compressibility, 1 over PSI, mu, viscosity, Cp, K, permeability, millidarcy, T, time, hours. So this would be also written like 1 over eta. This is 1 over eta, see? And instead of 5 UCT, 0.002637 K, we can put it 1 over eta. And what is eta? Eta is called hydraulic diffusivity. Hydraulic diffusivity. So what is eta in this case? Eta in this case is 0.002637 K divided by 5 UCT. 5 UCT. This is eta. It is called hydraulic diffusivity. So this is eta. See, here is eta. See, guys? Give me your attention, please. This is eta. See? So eta is 0.002637 K divided by 5 UCT. Eta is taken from this one. Now, what we have here, we have K. We're going to multiply K by H, and we're going to multiply the 5 UCT also by H. And then we will separate KH divided by mu. This is KH divided by mu. See? KH divided by mu. And what we will have down, we will have phi CTH. Phi CTH. Phi CTH. See what I'm saying? We just play with the math, no more than that. We just play with the math. Guys, if you couldn't catch me, if you couldn't understand me, please stop me. Stop me. Say, sir, I do not understand this point. Please repeat this point to me. Okay? Do not let me go on with my lecturing. If you do not understand me, if you couldn't catch me, please stop me. Now we do have two terms, KH divided by mu, and we have the second term, phi CT divided by H. Listen, these are really two important terms. Now, KH divided by mu, What is that? KH divided by mu. Do you know what is that? KH divided by mu. Have you heard about this term, KH or KH divided by mu? What is K divided by mu? Permeability divided by the viscosity. What is that? Have you taken enhanced oil recovery, guys?
No, sir.
No, sir.
Oh, no. Oh, do you know what does it mean, K divided by mu? K divided by mu? Have you heard mobility? Mobility?
Yes,
Moving.
okay, mobility.
Mobility is K divided by mu.
Yes, that's right, correct.
So KH, K divided by mu times H. K divided by mu times H. It is the mobility of the formation. See? Mobility of the formation. Or it is the ability for reservoir fluid to flow in the porous media toward the wellbore. This is the mobility. It is called, sometimes it is called transmissibility. It's called transmissibility, or sometimes it's called transmissivity. Transmissivity or transmissibility. It comes from the mobility, K over mu, times H, reservoir thickness. So it's gonna be what? The total capacity of the formation to transmit the fluid toward the porous media. See what I'm saying? This is the transmissibility, KH divided by mu. How about the second term, phi CTH? Phi CTH. What is phi H? What is phi H? Do you remember phi H? What is phi H? Have you heard about the storage capacity?
No.
This one is called storativity. Storativity. This is the formation capacity to store reservoir fluid. Okay. When we need to calculate initial oil in place, what we have to consider? We have to consider what? The bulk volume times porosity, gonna give you what? Pore volume. So what is the pore volume? The pore volume is the volume where we expect to find hydrocarbons. So as much as we have high porosity, as much as we are expected to have high pore volume, and this could give you more initial oil in place or more gas in place. Therefore, phi H times Ct, phi H times Ct, this would be called storativity. See what I'm saying? So in the diffusivity equation, actually in the diffusivity equation, this side, I mean the right hand side of the diffusivity equation, we do have what? We do have the transmissibility, we do have the storativity, and we need to know both of them. Can we know each from the diffusivity equation solution? Yes, we can know them. Unfortunately, in the well test analysis, we do not look for these two terms. We look for the permeability because we know how much H, we know how much mu H is going to give to you from geologist, while mu is going to given to you from PVD study. So what you need to know? You need to know what? The permeability only. So well test analysis is going to give you the value of the permeability. See what I'm saying? Okay, now we're going to have the disconnection. So it's less than 1 minute. So we will be disconnected and we are going to join me again. Okay?
Okay, sir.
Yeah.
Okay, sir. Okay.
Okay, I'm waiting. It is in my dashboard saying that less than 1 minute. So I'm just waiting to finish the 1 minute. And I will rejoin directly because we have started late. So I'm